Hi class, we're looking at section 2.7, which is finding the probability of dependent and independent events. You'll think of these as events that are having two things happening, or two types of choosing or occurrences. I don't want to say events, but it's basically a compound event. Two things are happening. What we talked about yesterday in the previous lesson had one thing happening. It was a single event. It was in theory. You rolled the number cube once. You reached your hand in a bag once and you picked something out, or you looked at the probability of picking something out. What we're looking at here now are compound events or two events. And there are two types of compound events. Independent events are events that do not influence one another. So let's say I have two jars or two bags of jelly beans and I reach my hand in each and try to pull one out. Those are independent events because the bags are separate, okay? Now, so these would be the types of things that you've been seeing in your probability that quizzes, that you have two ponds, or on Monday you pick a hotel room and on Friday you pick a hotel room. Those are two independent events. It really doesn't matter what happened on Monday. Friday is a whole different thing happening. Now, dependent events here we can see are events that influence one another. The occurrence of one event affects the probability of the second event. So you want to think about, if I have, let's say, 5 jelly beans and 2 are green and 3 are red, okay? So I eat a jelly bean from my 5 jelly beans. I only have 4 left. So if I'm going to eat another jelly bean, the probability that that jelly bean is red or green is going to be different than it was the first time I pulled a jelly bean out of my bag that only had 5 in it. So dependent means it matters what happened the first time, because now I have less things to choose from usually, okay? Let's look at some examples here. Suppose you have, you roll a number cube. What is the probability you will roll an odd number on the first cube and then a multiple of 3 on the second? Well, does it matter what happened on the first roll? No. The number cubes don't have any kind of memory. All right, we have memory, but the number cubes don't. So it really doesn't matter what happened on that first roll. The probability of getting a odd number on the first roll is going to be 1/2, right? Because we have 1, 3, and 5, which is 3 out of 6. And you always want to work with reduced fractions. It's much easier. So that's the probability of getting an odd on the first rule. Okay, now the probability of getting a multiple of 3 on the second cube is the probability of and I'm just going to put a multiple or a times 3 there to show multiple of 3, is going to be 2 out of 6. 3 and 6 are multiples of 3, and I'm going to reduce that to 2. 6 reduces to 1/3. So now the probability of having an odd number on the first one and then a multiple of 3 on the second, we multiply those fractions together, 1/3 or 1/2 times 1/3, and we get 1/6 as our probability there for that situation. Okay, so the probability of rolling an odd number and then a multiple of 3 is 1/6, and I'm going to take the 2, the 1/2 and the 1/3, and multiply them together, because that's the probability of the first event and that's the probability of the second event, and they're independent. Okay, let's move on to example 2. Now, without replacing, this is where it matters what you do the first time. Suppose you have 3 quarters and 5 dimes. You take out 1 coin and you don't put it back in, and then you take out another. What's the probability of taking out a dime and then a quarter? Okay, so first of all, what's the probability of getting a dime? Okay, this is the first event. We have 8 coins in our pocket, and 5 of them are dimes, and there's 8 total. So that's a probability of getting a dime. Now let's assume we get the dime, and then the probability of getting a quarter now. How many quarters are left in your pocket? Well, there are still 3 quarters there because you got a dime on the first one. So there's 3 quarters, but now there's only 4 dimes instead of 5. So now it's out of 7. Do you see how the difference, when we don't put that coin back in, now this second event, we have less to choose from. That's called a dependent event, or sometimes it's called without replacement, which means we pull something out and we don't put it back in. So we're going to multiply those two together, and we get 5 times 3, which is 15, over 8 times 7, which is 56. So the probability of taking a quarter or out a dime and then a quarter out of your pocket without feeling around is going to be 1556. Okay, and that can't be reduced at all. I know you kind of want to, but it doesn't. We'll do some of those quick checks tomorrow in class, but let's look at the third and final example here. This is applying probabilities of compound events, and a teacher must select 2 students for a conference. The teacher randomly picks names from among 3 freshmen, 2 sophomores, 4 juniors, and 4 seniors. What's the probability that a junior and then a senior is chosen? So let's look at, first of all, what's the probability of picking a junior? A junior is going to be 4 out of the total of 3, 5, 8, 13. Okay, 5, not yes, 4 13ths. And then the probability of picking a senior now. Now remember, the seniors, there are 4 seniors, but we've already picked a junior. Okay, we've already picked a junior now. So we only have 4 12ths now, which reduces to 1/3. Okay, so the probability of a senior is going to be 1/3. We multiply those together and we get 4 over 39. That's the probability. Okay? That's it for the lesson on compound inequalities. Again, you want to look at with these events, since you have 2 events happening, okay, it's important that you think about what happened first, and then also, are you putting that back in? Okay, most of the probabilities you've been working with on your that quizzes are independent. It really doesn't matter what happened on the first try, because you're looking at a different pond or a different box of candy or a different night or something like that. Most of the ones we've been doing are independent. Dependent are a little bit more challenging, and you won't see these as often. Okay, and then of course we have our single events, or a theoretical probability, which is just looking at one event. Good luck. Don't forget to do the check your skills you should know. That'll review some fractions for you, and I'll see you in class tomorrow.